Page 3 and page 4. With page 3, we just have one problem. We are given this graph of f prime, and we need to figure out which of the following could be the graph of f. All right, so what do we know? We see that the graph of f prime is negative, and then positive, and then negative. So we need a graph of f. We know that is, oops, let's try it again, decreasing, then increasing, and then decreasing. That's the only way it's going to match. So we've got to decrease from 0 to 1 and decrease from 5 to 6, because that's when f prime is negative, and it will be increasing in between. So if we look at this, this graph is decreasing between 0 and 1 and 5 and 6. So that's in. This potential graph of f is decreasing from 0 to 1, but then again it decreases from 3 to 5. So that's out. This graph decreases from 0 to 1, and then again from 5 to 6, so it's in. And then last but not least, D is not decreasing from 0 to 1, so that's out as well. All right, so what's next? Let's go back up here, and we see that we have at x equals 2 and 4 and 3 for that matter, we have f prime having relative extremes. All right, we're changing from increasing to decreasing, from decreasing to increasing, from increasing to decreasing. All right, so at 2, 3, and 4, all right, f, all right, when x is equal to those values, f has to have a point of inflection. All right, a point of inflection, because f prime is changing from increasing to decreasing or decreasing to increasing. Well, at 2, we see a point of inflection. At 3, we see another point of inflection, right? Concave up, concave down, concave up. And then right here at 4, we see a third point of inflection, concave down. So A still fits. Right? C, we do see concave up, and then concave down, concave up, and then concave down. So we are having a change, but there's the function's not continuous. So go back up here and let's just make sure we're good with this. We see we have a sharp point, but that's okay that we have a sharp point. F will still exist. F double prime will not exist at the sharp points, but F will exist. And here the function does not exist at 2 or 4, so C is out. Our answer is A. On the next page, number 7, we're told that f is differentiable and increasing. All right, so if f is differentiable, that means that f prime exists. And if f is increasing, that means that f prime is positive. All right, the graph of f has exactly one point of inflection. All right, keep that in mind. I'm sure we're going to come back to that. Of the following, which could be the graph of f prime, the derivative of f? Okay, so we know that f prime should always exist and that f prime should always be positive. Well, if we look at our options, that's negative, so B's out. That's negative, so D's out. That's negative, so C's out. Only A and E are above the x-axis for what we can see here. So those are our two options. So which one do we pick? Let's go back to the idea that there's only one point of inflection. That means that f prime changes from increasing to decreasing or decreasing to increasing only once. Right? It should only happen one time. Now here's decreasing to increasing one time. Here's increasing to decreasing once, decreasing to increasing twice. So E is out, and our answer is A. With number 8, particle moves along the y-axis. The graph of the particle's position, y of t, and time is shown. All right, so this, in essence, this is like our f of x. Okay. For what values of t is the velocity of the particle negative? All right, so v of t, which is equal to y prime of t, because we know velocity is the derivative of position. Right? It has to be negative. And the acceleration, so a of t, which we know is equal to the second derivative of position, must be positive. All right, so if the first derivative is negative, that means that the original function must be decreasing. And if the second derivative is positive, that means that the original function must be concave up. So we want decreasing and concave up. Well, here's concave up but increasing. Here's concave up but decreasing. So it starts at 4 right there, and it ends at 5. So our answer is D.